Welcome all back to the program. And next we will shortly hear about the results from the project that Yrityssalo and Turku Science Park are running together. It started in August 2020, and Johanna and Raimo will now shortly tell about the results this far. So it is a EU-funded regional development project that makes it possible for Yrityssalo and Turku Science Park to be building up this battery network. So please, Johanna and Raimo.
Thank you, Linda. Sorry about minor error here. We made interviews in the southwest Finland area to the companies, and our plan was to find out what kind of know-how, future plans and needs companies had related to the battery value chain. And also we wanted to gain insight into what would they need in order to succeed in this field in the future. We made 12 interviews and we tried to cover the whole battery value chain, the main parts of it. But clearly our emphasis was in these two parts, so from battery cells to battery packs and in the applications area. And our grounding for this emphasis was that we think that the new business opportunities would be created the fastest in these areas, and also these areas are important in the Turku-Salo area because, for example, we don't have mining here. But we are making good cooperation with Pori region with a sister project, and they have also, of course, materials, chemicals, and circular economy operations there. So what did we find? This time we are concentrating on the strengths of the southwest Finland. And for example, we have good knowledge of development and testing of industrial scale solutions for land and sea use, both on the land and underground. Solution development for maritime applications. Of course, production of battery systems for electric vehicles and research and development related to that. Battery performance testing and sustainable recycling of battery materials. Because there is digitalization and automation expertise in this area, so there is then, of course, skills for the operation of and use of battery-powered applications. Talking about future opportunities, we found out that in order to catch these opportunities, an attention should be paid to several points. In the future, it's even more important to combine the expertise from different fields. It's really important. So there has to be several kinds of knowledge and skills. There's much potential to use hugely more AI and IoT skills in the battery sector. That's an opportunity. It's really important for many players of the field that we would increase the testing capabilities and capacity here in Finland. This includes also testing larger energy systems. And in this new developing field, all the regulatory framework is important. If this was taken care of nationwide, it would alleviate the uncertainty. There are lots of different kinds of regulatory aspects for approval, fire safety, recycling, circular economy, for example. Then some other areas that seem to need attention and preferably also action. You cannot emphasize too much charging infrastructure, and more broadly the electricity generation distribution. Renewing and planning them is essential if we want to develop electric public transport, heavy transport and logistics. There is also some difficulties to find right kinds of experts now and in the future. This is important to somehow deal with, and it has been shown that finding know-how in Finland is sometimes hard. And we figure that the world is evolving so fast and businesses must evolve so fast, so the traditional educational system doesn't necessarily keep up with that speed, and that implies that there needs to be new forms of business and university cooperation in this field. But overall, circular economy is perceived as an opportunity for this new industry sector, and it seems that if we can build comprehensive solutions and combine the Finnish know-how, we can build new export businesses that can reduce emissions and also advance circular economy in European and global level, even though some single solutions might have a minor role alone. Now I hand over to my colleague Raimo, who will continue with further results. Go ahead, Raimo.
Yeah, thank you, Johanna. Please change the slide. Yes. So when we interviewed the companies, we collected the results and made some interpretations. And one area which already mentioned by Johanna is that the applications area. It's a very wide area, at least in case of if you depict the value chain as seen in the slide. You talk about cars. You talk about different kind of mining vehicles and things like that. So that must be reviewed and handled in more detail, because at least we think that the biggest business potential and expected there. And to mention a few areas is the artificial intelligence, IoT, will play a important role in the battery value chain. And the intelligent use of batteries must be thought in a comprehensive way in the energy solutions. Other things which we found from is that the testing capabilities and capacity is needed in Finland, that we don't have enough resources to do that comprehensively. And yeah, Johanna already mentioned that new kind of industry cooperation are needed. And also we need to find ways to utilize the funding mechanisms coming from European Union and elsewhere much better. Next slide. As a conclusion, that when developing solutions for the battery value chains, we must utilize this AI and IoT and material technology as well as intelligent manufacturing. And to say that Finland must find the right focus area, which was also emphasized by Finnish Material Group. So and invest enough. That's also very crucial, that to make the growth possible and to become a world-class player in the chosen area. And as an example, it seems to be that the rest of the world is mostly focusing on EVs. So we must find an area which is a large enough niche area. And those who are Finns knows that in the maritime industry, the cruise ships are kind of very highlighted in Finland, and they have been very successful. So these kind of examples, these kind of areas must be found in for Finnish industry. The final slide. Then we have some action proposals. Based on the interview feedback and actually supported also from by the Batteries from Finland report, that it seems to be that Finland has a good position in developing battery applications for the harsh use, like mining applications or some utility vehicles. And we also have a very good chance of large-scale recycling of lithium-ion battery materials. And we actually need to launch national projects to support growth in these areas. And finally, this is our kind of strong statement that we might need to have a national-wide effort to enhance our testing capabilities and capacities. And this is not only for battery cells, but also larger energy systems. Like in case of maritime, you might need to have the whole energy system for the whole large ship. And finally, we urge to seek more ways to utilize the European funding. So I conclude this my part, and let's move forward so we don't waste so much time in this part, because the industry talks are more important. Thank you.
Thank you, Raimo. Yes, we have a quite tight schedule today, so let's move on forward. And the main headline for the coming presentations is batteries for harsh use. And I will be moderating session 1. And let's start with Mr. Tor Stendahl, the country manager at BASF, and he will give us an insight in BASF's actions in Harjavalta and investments, but also on a wider scale on battery activities in BASF. Please, Tor, go ahead.
Thank you very much. Is my screen visible and my voice can be heard well?
Yes, everything
Perfect.
is okay.
Good. So first of all, thanks very much for inviting me to speak here. It's great to be part of this project here, and I'm really always happy to talk about what we are doing up in Harjavalta and Europe on a whole. Maybe just starting off briefly with BASF, the company, who we are. For those who are not familiar with BASF, so one of the largest chemical companies in the world, and have a turnaround 60 billion euros. Local, I mean, 120,000 people worldwide working for us, and I think what's maybe here is important that I mean we say that we create chemistry and we create chemistry for a sustainable future. And when you think about sustainability, you need to think not only about the environment, but it also has to be economically viable and socially responsible. So we have to combine these three things: environment, economy, and social aspects when we think about sustainability. We have production plants, and we call these so-called Verbund sites, which is more or less it's integrated business sites. So for instance, our site in Ludwigshafen in Germany, it's about 10 square kilometer area with 300 factories in the same area, operating the whole value chain of BASF on one site. And that's one of the strengths that we are using to have that whole chain in ours. And it's of course from a sustainability point of view also important, because we can keep all the transports on the site in pipelines. We can use excess energy from one plant to another, byproduct from one production as raw material and the next one, all on one site. And these are the things that how we operate. This is our DNA, and that is something that we also bring with us when we come later on to talk about Harjavalta. If you look at what we're doing in Finland, everything is a little bit smaller scale. Today there's about 95 people working for BASF here in Finland. We have an office in Helsinki. We have a production plant in Hamina producing paper binders for coating of paper and board. We have a small warehouse production facility in Vantaa making refinish coating, so paints for car repairs, and also a small office in Tampere for metal working products. But of course, what's the focus for here and is the construction project for a PCAM plant up in Harjavalta. And as we've also publicly said, this will create more than 100 jobs in Harjavalta, indirectly or directly. So you can see that it has a huge importance for BASF and our activities in Finland going forward. I told you already, our purpose is creating chemistry for a sustainable future, and this is driven very hard by our CEO and our leadership team. And what that means in practice is that we want to be a thought and action leader in the area of sustainability. And we also want to increase the role of sustainability in our business decision. And this is also one of the reasons why we come to Harjavalta. I mean, this is, we can, and I'll come back to that a little bit more, but these are things that we are working on, and other key measures, for instance, decoupling our CO2 emissions from our organic growth. So we want to grow CO2 neutral until 2030. So sustainability is at the heart of us, and that's very important, of course, coming from a chemical industry that's extremely energy intensive. Also, when you look at how we look at our commitment to the industry to reducing the CO2 footprints, for instance, is we have to look at the whole value chain. And here also it comes back to what I want to talk about. No one can do this alone. So we need to find the right partners to source our materials responsibly for. We need to be able to build up a production where we can produce safely, both for people and the environment. We of course have to have a very efficient production footprint, and then that's all the things we can do ourselves. And of course, then our there you can talk about the CO2 footprint, and then you can talk about the CO2 handprint is actually where our products come in and support our customers in reaching their targets. And not to forget about the people, of course, never. But this, and here also a slide that very much shows how we are doing the thing, how Harjavalta fits in here. So we will talk about our cooperation with Nornickel for getting the nickel and cobalts to our site. We are building up a new state-of-the-art facility to produce safely, efficiently, and filling all the criteria for the environment. And the product that we are producing will, at the end of the day, reduce the use of fossil fuels, because we are supporting the build-up of the EV value chain in Europe. So I think you've all seen these slides, and these are, of course, the big challenges that EU is facing now. So how can we here in Europe build up a sustainable and competitive battery value chain? And have the assets here in Europe, because today, as Matti also showed previously in his presentation, we are extremely relying on materials from abroad, and so we need to get the footprint here. We need to find ways to source the metals responsibly. We need to build up value chain with the lowest possible carbon footprint, and of course we need to find solutions to get the batteries back in, and the metals in the batteries back into and recycle them, so we get them back into the value chain. So where do we fit in here, and why is BASF in here? I think it's important to understand that BASF is actually the most important industry for BASF globally is the automotive industry. So we are a huge supplier of the materials there, starting off with automotive catalyst, for instance. We have the plastic for cars, which is growing now that you want to reduce weight in cars, so you use more plastics in the car. We are producing the car paints, we are producing fuel additives. So we've always been heavily into the automotive industry, and of course, therefore, the battery value chain is very important for us going forward to maintain this position when we see this big transition. And where we come in is producing the cathode active material. So we are not looking at mining, and we're not looking at the battery chemicals, and we're not looking downstream either towards the cells. So we are buying the metal salts to produce the cathode active materials, and our customers are then the cell manufacturers of the world. We're also looking now into the recycling. That's something that we do anyway for all our catalyst business. We are very well already working on metal recycling of these valuable metals. So this is something that we want to also use our expertise to bring that to the market. And with the investments coming here, we will then also have a global footprint, both for R&D, technology centers, and production. And if you look at that footprint having today, so already today we are producing in both in Asia and in the US cathode active materials, and have our technology and R&D centers all around the world. But what is then ongoing now is, of course, our heavy investment into Europe, where we are building 2 plants, one in Harjavalta and one in Schwarzheide. Harjavalta to produce the cathode or the precursor material that we will then ship down to Schwarzheide in Germany to produce a cathode active material. Why are we doing this? Matti also showed a couple of slides related to this. I don't know if these are new or older, but here you can see the expected growth of EVs for Europe, and I think it's quite astonishing to see how the growth is increasing here. So as you can see, with 1.2 million cars in 2020. Going up to 4.7, and actually the light green part here is how much the market has grown in only 1 year. So the dark green here shows the estimation in Q4 2019, and then this add-on 18% here is the growth potential that came during 1 year. So you actually can see how the growth is strong. Maybe here on the right side, it's interesting to also see how the COVID crisis has affected the car manufacturing. So in 2020, we saw a sharp drop in car manufacturing. A lot of the car plants had to close down because of the COVID. And what you can see here is that the market or the production for combustion engines will never ever more come up to the same level they were before the COVID crisis. So here you can see how the EV market now is taking over the market here. So that's what's looking for, and we are looking for. And here is also another picture, and I won't go much into that because here again I think Matti showed that in his presentation. But there is a huge number of investments, especially into these gigafactories in Europe. And so already here on this side, Europe has been able to attract interest and investments. Some are already producing, but most are projects being planned. But if you look at upstream from these, as also Matti said in his presentation, there is definitely a big hole. So when you come to cathode active materials and the battery chemicals, Europe is completely relying today on production coming from mainly from Asia for these materials, and that's where we are coming in here with our project. So as said, our goal here is to create local production for cathode active materials with our 2 sites here in Harjavalta and Schwarzheide. And the plant that we are building, that you can see on the picture here, we are not building it inside the industrial park because there was not room enough for us, so we bought 14 hectares of land outside the park. But we are connecting ourselves to the park. The main reason for being here in Harjavalta is, of course, our commercial agreement and cooperation with Nornickel, who is supplying us with nickel and cobalt sulfates from their factory in the industrial park. But other very important parts here are the fact that and I think that was also previously talked about, that the availability of CO2 neutral energy or green energy, renewable energy, and that is of course something that is going to be very important for the value chain here in Europe, that we can build up our production footprint using renewable energy. But also, and here I come back to when I alluded to our Verbund thinking, we also want to connect this site to the industrial park and make use of all the existing solutions that an industrial park can have. So we're building a pipe bridge over to industrial park to get utilities needed for our production, be it water, be it steam, and other utilities. So we are using this and becoming part of this and creating sort of a Verbund in Harjavalta with the different companies working in the industrial park. Our plant here is planned for a production capacity of approximately 400,000 fully electrical vehicles per year. And this is just the first stage. So on the picture here, you can see, so here we will have that capacity, but all the land behind here is planned for extension of our production. So the idea is to then, with a modular plant concept, to be able to very quickly then react to the demands and put up new plants as soon as this one is now up and running. And the plant startup is next year, so there's still some work to do to be ready to go with this one. Here you can see a timeline of the project, and it's been a long project. I mean, we started this, I think we actually started in 2017 already, first discussions with the ministry and the city of Harjavalta. But then came in land purchasing in 2018. We started the EIA process in summer of 18, and as you can see here through our timeline, a lot of things have been going on here to be able to then hopefully, or not hopefully, but we will be able to start up in 2022 our production. Maybe some points here worth mentioning. I always like to say, I mean, we are really grateful for all the support that we've received, both from the Ministry of Economic Affairs, from Business Finland, especially from the city of Harjavalta, which has been very supportive of us throughout the whole process here. And I think one good example was when we did the EIA submission. This was done just before vacation time. We submitted it, and we wanted to have a discussion with the neighbors straight on before they went on vacation. So we had a meeting with them, invited them together with the city, talked about the project. The most important thing they had on their mind was, we don't want all the traffic coming close to our houses. What can we, that this is really a concern for us. So we talked with the city, and even before the first public hearing, we decided to build a new road to the site, and it got the name Akkukatu. So this is just to show a really good cooperation with the city. Of course, we work with Business Finland TEM. We participated in the IPCAI funding and received a positive result there, and very grateful for that. We've received the chemical permit. We got the environmental permit. You can see it took 2 years for the process with the authorities to get the environmental permit. Now we are in the recruitment process, and as I said, everything is working on time to be able to start up the production here. Maybe one point I like to mention here also, when you think about these partnership and bringing all the companies in here, that's important of having the tools to get the companies to come here. Because I think you all read the newspaper, you see that Finnish IPCAI investment value is around 25 million of subsidies. Germany had 1 billion, for instance, and these big gigafactories that we are talking about. Tesla, with their production in Berlin, they are getting subsidies of 1 billion euros from the German state. So I think that's an important thing here also for the Finnish government to think about. What kind of tools do we have to support and to attract the companies to come and invest in Finland? Because again, this is going very fast. It's very expensive investments, and at least if you look at the gigafactories, they go where there is the best support and infra available. And I think we have a lot of things talking for us, but I think that's a little bit learning that I got on the way here. No one can do this alone. This is a value chain where a lot of partners are participating, and here is just one example of how we want to be part of this value chain. And this is we've also now said and really like to talk about the cooperations we are doing up in Harjavalta on looking at a recycling cluster between BASF, Fortum, and Nornickel. And I think that Kenneth Ekman will talk more about that in his part also. But as you can see, in Harjavalta, with our PCAM facility, we will be actually, and Nornickel's refiner, we will actually be able to close the loop of the battery metals. So also using the scraps coming from the different value chains, collecting the materials, doing a recycling. Both BASF and Fortum have good knowledge in this area. There we will be able to bring back the metals into the value chain, into Harjavalta, and get them back into the precursor plant. So we actually have a real closed loop system being built in Harjavalta. So to wrap things up, I mean, we aim to be the most sustainable cathode active material producer globally, and we take our responsibility throughout the battery value chain. And here you can see the examples. So we are partnering up globally to ensure a resilient and sustainable metal supply chain for our customers. We'll have the global production presence so that we are always close to our customers. We have an energy efficient production, minimizing our footprint as far as we can do from a technology point of view. We are building with the ability to invest and enlarge our production so we can grow with our customers, and we are investing into the recycling and to close the loop, and thereby offering the best in class CO2 footprint and helping to reduce the total footprint of the EVs in the market. That was my presentation for today. Now, if there are any questions, I'm happy to answer.
Thank you very much, Tor, for your interesting presentation. I think it's so nice to hear about your holistic grip on sustainability and also about this new recycling cluster that you are building up in Harjavalta. We do have one question. If we get a really quick answer to that, because we are running out of time, but it's about the permitting processes, the environmental chemical permitting processes and the difference between Finland and Germany. Could you shortly, Tor, please comment on that? And maybe for a longer discussion than later on.
Yeah, I'm not an expert on the German environmental permitting process, but I have to say, I mean, I think I can just say that for the Finnish one, I think there are a lot of good things with the Finnish. It's very transparent. It's a very structured process. You know what you get yourself into. It could be faster. I think that's what I would like to bring here.
Yeah. Thank you, Tor, once again. And then we will continue with the program. And the next speaker is Mr. Mikael Mäki, who is the manager of the corporate communications at Valmet Automotive. And his presentation is about batteries from innovation to delivery. And I will share my screen. So we will. Mikael, is it okay now?
Yep.
Please go ahead.
Thank you. So thank you very much, first of all, for this opportunity to participate in this webinar and to present the activities of Valmet Automotive to such large and professional audience. Now, on the first page of the presentation, please. Yes, so here we can see pretty much the historic landmarks that our company has. Valmet Automotive is one of the leading and most versatile service providers for automotive industry already for over 50 years. And as the chart shows, we have made our reputation over the years working with leading OEMs, especially in contract manufacturing of cars. In 2008, we were one of the first players in the automotive world to focus on e-mobility in the company's strategy. And as we can see here, the very next year, in 2009, we started with the series production of our first EVs, which were incredibly enough full electric vehicles. And then 10 years later, in 2019, we took another giant leap towards e-mobility with the launch of our first high-volume battery production plant in Salo. At the moment, our all three business lines base their strategies on e-mobility. For example, in contract manufacturing, we are currently manufacturing 3 different EV models in Uusikaupunki. On the next page, here we can see how Valmet Automotive services cover the whole value chain in batteries. We have concepts, development, prototyping, testing, and finally production. The point here is to understand that at Valmet Automotive, we are expanding currently our technological base. We are now focusing on 48-volt batteries and contract manufacturing, and this is what we are doing in Salo at the moment. But we strive for the tier 1 system supplier role in batteries. And therefore, we are currently investing heavily into all the phases that precede production here. So we are producing modules and battery packs, but we are also producing components. And as we are striving for the tier 1 system supplier role, we want to produce high voltage batteries of 400 or up to 800 volts and develop platform modules and battery systems. Next slide, please. Here is another view of the expansion of Valmet Automotive's activities in battery business, this time through the applications, and we have a diverse, large portfolio of applications. Currently, as I said, we are focusing on the 48-volt batteries that are mainly meant for passenger cars and vans, because these batteries go for the so-called mild hybrids. And mild hybrids are usually used in these types of vehicles. But as I said, we will be manufacturing high voltage batteries of 400 up to 800 volts for these vehicle types too. And as for the other highway vehicles, utility or heavy traffic vehicles such as trucks and buses are a very obvious direction for our expansion. And especially here in Finland, we are very interested in the possibilities offered by the so-called off-highway segments. These are working machines that are used in mines or forestry or agriculture, etc. In the off-highway segment, the requirements for batteries differ very much from the highway vehicles, but we recognize a huge potential here. Next slide. I have now previously explained Valmet Automotive's expansion from the technology and application points of view. Now, this page shows what all this means in practice. In this year alone, we have great steps to take, and we are moving forward with our strategy. In Salo battery plant, we are expanding within less than 12 months of operation due to the growing demand for battery packs. For the very same reason, we are building a second high-volume battery plant in Uusikaupunki. We are also preparing for the system supplier role with strengthening our engineering resources both in Finland and Germany. I believe at the moment we have something like 50 positions open for applications for engineers, both in Finland and Germany. And then we have just recently extended our battery test center in Germany. And even as we speak, we already are making plans for a third battery plant, although most likely this will not be located in Finland. So on the next slide, building the future. Valmet Automotive has been extremely active and fast in its actions in battery business. This is a business that is currently emerging and taking shape, and therefore it's offering huge opportunities. It may be a disruption, but certainly the situation is a game changer for the automotive industry, but also in many other industries, and indeed in entire societies, as has been already mentioned here. And taking the magnitude of this change into consideration, we at Valmet Automotive are very pleased with the role of the Finnish government that they have taken and how they have actively promoted a national battery strategy and cluster, because at Valmet Automotive we have seen that cooperation and collaboration are the ways to success and to get to the top. So in a nutshell, that was what I wanted to tell you at this time. Thank you for attention and interest.
Thank you, Mikael. We will hear. Yeah. Thank you, Mikael, for a very clear and interesting presentation. We are a little bit running after the schedule, so I think we will take all the questions after the session. But I think we got a really good overview of Valmet's activities at the moment. Thank you once again. And the next speaker is Mr. Mats Eriksson, the Managing Director at Sandvik Mining and Construction. And he will tell us about real harsh use electrification and what it's about in Sandvik's business. Please, Mats.
Thank you. I will share my presentation here, but thank you for the opportunity to speak in this event. I think Sandvik is a bit of unknown in Varsina-Suomi, and let me get it a bit more known through this presentation. I hope you can see the presentation at the moment. I have two roles. I have a global role leading Sandvik's load and haul division in Sandvik, which is a division split between Finland, China, US, and South Africa, where we have operations. And then I have a local role as managing director of, or you could call it country manager of Sandvik in Finland. Not going into details about Sandvik, but it's a large company. The 103 billion SEK means about 10 billion euro of revenue. And of that 10 billion, 1 billion is coming from the Finnish operations. So Finland has a major part in what Sandvik is doing. And the part Finland is playing here is, as the name says, very much into mining, originating in old Tamrock that Sandvik bought. What I'm going to talk about is electrical application that we are working on, and might be news to some of you that we are a market leader in underground load and haul worldwide. You can see the equipments there, the trucks and unloaders. They are all developed and designed in Turku, and there are more than 100 engineers working on this every day, and of course we have a lot of subcontracting as well. We are really market leader when we talk about diesel equipments, but the world is moving into electrification. And why is that? It's not because we have regulations from let's say different governments or countries. That is one small part of it, but the big part is that when you put a truck or a loader 2 kilometers underground, you have a closed environment, and you can all imagine that it's not that healthy to have diesel fumes in those areas. So workers' health is a big thing. Also the noise and the heat generated from diesels are not good to have in a closed environment. Then we have economics that is really driving the whole thing besides the health. And that is almost 40% of the cost of underground mine comes from ventilation and cooling. It's deep down there, it's hot, and you need to have oxygen for the workers. So it's a huge cost that you can reduce if you take away fumes from diesel engines, for example. So that's driving it. And then, of course, the global sustainability, let's not forget that we are in that area. So there are economic and health drivers that is driving us into the direction of electrification. So that's important to remember. It's a business. If you look at what we have done here in Turku, actually, is that we have been in this electrification area because of the economics and health aspects a long time. We have delivered already 600 electric loaders, but those are cable electric loaders, so they are connected all the time. They are not battery driven. In 2019, we acquired a US company that is a front runner and has battery electric loaders and trucks in about 10 years. And we acquired that to get the expertise and knowledge. But naturally, we have a lot of expertise and knowledge in Turku as well, so it's not all there in this US company. But the combination of that means that we are clearly a leader in this game also, when we talk about the mining industry. Nobody else has battery electric units in operational use than we. So Sandvik is the only one worldwide having that. We have, of course, looked at different solutions for how to electrify and how to use the batteries. And we have had to choose the swap system. We cannot have fast charge. And you see this on this picture. To begin with, we don't have enough of power in the mines to really have fast charging. You need to charge them in 15 minutes then. Please remember that these units are used 24/7. There is no stop where they stay in a parking lot like a car. They are in use all the time. So you cannot have a lot of breaks and stops of them. And we have seen that by swapping the battery, you can get more productivity and be actually have a better infrastructure in the mine. And that's purely because you don't have the power density in the battery pack that is needed for this heavy use. So you could use the machine for example 6-7 hours. If you could do that, then of course it's a different story. But at the moment you can run a truck or a loader about 2 to 3 hours. Then you have to swap the battery. So we have gone for the swapping as the only solution. And on the next slide, I will show you how the swapping is made. And this is a real truck that has already been delivered to the customer, but it looks like this. I hope I can get the video to run. Hope you see it. It's of course speeded up here. The guy disconnects from the charger the battery pack and disconnects the battery pack that he has on his truck. And then he gets into the truck, and we have two batteries. We have this big battery that is actually for the operational use, and then we have a smaller battery in the truck, so he can still move while he takes the battery pack off. Then he goes and picks up the fully charged battery like this, and goes out and connects to the charger, the one that he dropped off, and then he will of course connect the battery pack that he just lifted on the truck. And you can see that this takes about 6 to 7 minutes to do a change. And this is the way we do it with both. Can you still see it? Hope so.
Yes, we can see it.
Good. All right, then let's move on. some reason my computer hang already. I'm taking it again. Let me skip. To the next page. And because you are in an environment that is closed and underground, you should not have an issue with the battery that it will cause a fire or you will get any other safety issues. So if you look at how the battery pack is put together, you can see what is the common word in each and every layer is safety. And that is a must for us. And that is the big issue. You have a battery that is around 7 tons of weight and there is a lot of energy in it. You cannot have any safety risk with that. It's in a tunnel, it's in an area where you cannot get out if something happens. So safety is a must and there is no compromises here. Which in practice leads to the situation that what chemistry can you use? We are choosing the lithium iron phosphate because we see that being the most safe solution. And the company we bought has had this lithium phosphate iron or iron phosphate in the mines for about 10 years already. They have had a few issues where the battery has got dropped and it has been hit hard or there has been big stones falling on it and they never got to safety issue. So it's kind of proven in the real world. And of course, this is what we are aiming at. There are a lot of good things with NMC, but because we cannot make the NMC battery pack safe today, we cannot really use it. Then if we would move into fast charging, I think LTO would be the area we would look at. And we have tested that. But it's the fast charging is not usable at the moment. So with this very brief introduction, I thank you and I can easily say that we are a market leader when it comes to the current situation and we have to develop these applications, BEVs for the mining world, to stay as a market leader. There are no compromises there. We are a global company. If we cannot find the expertise and knowledge in Finland, we have to go elsewhere. At the moment, I'm quite optimistic and think that we can do things in Finland. We have, among others, sponsored a professorship in the University of Turku to help out with the education in this area, and that is focusing on electric drivelines. So I do believe that we will have the expertise available in Finland. To make a long story very short, what we need is safe batteries and recycling of them. That's what we need. We haven't got the solution for it yet, but we are working on it. So whatever help we can get from companies around us, we are pleased to look into it. Thank you.
Thank you, Mats, for again a very clear and interesting presentation and also for giving us an insight in the biggest drivers for Sandvik for electrification, namely health and safety. Now we have 2 questions in the chat and we also have time for the questions. So firstly, here's a question from Kenneth Ekman. How have you planned the recycling of LFPs? I think this was one of the points that you also mentioned, Mats.
Yeah, if I had an answer for it, I would be really cheerful and happy and ready to spend my weekend. But unfortunately, I don't have an answer because we haven't found a solution for it yet. We haven't been that active either, as the volumes are not big. But the mines are, of course, globally around the world. They are as well in Chile, as well as in Africa or Australia or Canada, that is a front runner in the mining world for this. And the customers are asking us, and we don't have an answer at the moment. So we have to build up that infrastructure. It's not there.
No. Well, it's good that everything isn't ready, so we have still work to do, and we can enlarge the industry and competencies. There was still another question. Do you foresee that? Excuse me, I need to take it here. Are coming so many chats. But it was about do you foresee that you could use or develop further the battery pack, for example, for long-haul transportation?
Yeah, absolutely. I think the company we acquired actually made some, let's say, trucks for road use really before, and it's possible. But I think what we are facing is that it's not that easy to swap batteries anymore when you go for road use. In a mining, you have a easier environment as it's very closed and it's very small. You can actually have a charging station that you always can turn up to, and you can't have that when you go for larger environments. So you cannot swap it. That is the limitation here.
Yeah, that's true. Yes, and we're very happy that you brought up Turku, because in this session we had one company from Pori region, Harjavalta, that was BASF, and then the self-evident Salo with Valmet Automotive. But it's also very good that we put Turku on the national battery map. So we have quite a few interesting actors here in the region, and we now want to just make the network stronger between the cities and also a national level. So thank you, Mats. And now we will move on to the next session, and it is Raimo Vuopionperä from Turku Science Park who will moderate that session. And it starts now at 11. Please go ahead, Raimo.
Yeah, hello. Hopefully you see my slide, which is visible there. It's a little bit hard to at the same time to speak.
Yes, we see it. We see it. It's okay.
Okay. So the next session, unfortunately, we had to skip the break for time being, but next session is about from transport to logistics, and actually Mats already touched about that. Is that it's not only about batteries, it's also about applications, and they range from mining to even logistics solutions, and you also need the chargers. So the next speaker is Juha Parkkonen from Turun Kaupunkiliikenne, and he will tell about the experiences of electric bus traffic in Turku. And I stop my presentation now, so please go ahead.
Okay. Hello everyone. I'm Juha Parkkonen. I will start my presentation over here in one moment, please. Okay, so I'm a CEO of Turun Kaupunkiliikenne Oy, in English Turku City Traffic Limited, and we have some experience with operating with the electronic buses, and that's why we are asked to participate this event. So electric transportation, public transportation is nothing new in Turku. The first electric tram cars was started in 1908 in Turku, and they operated until to the 70s. And just before the oil crisis, the city decided to get rid of them and arrange the public transportation only with the buses. and everyone or the local people at least know that at the moment there's a lot of conversation about re-emerging these tram cars to Turku also.
Juha, can you make the presentation mode?
Okay, you can't see it.
We can see it, but it's better if you can presentation mode. It is visible. It was visible, but use the presentation mode.
Okay, this is a PDF. Maybe I use the PowerPoint. Is it better this way? One moment, please.
If it takes time, then we survive with the first one. Yeah.
How about now?
Now good, thanks.
Okay. So the Turku City Traffic Limited, it's a bus operator which is owned by the city of Turku. Our turnover is about 8.5 million euros in a normal year. Last year has been exceptional because of the corona pandemic. We transport about 5 million passengers per year and drive about 2.5 million kilometers inside the Turku area, and our market share is about 20%. At the moment, we have about 110 persons in a company, and we are operating with 45 buses, which include 6 electric buses and 4 hybrids. These electric buses are used in the bus line number 1, which runs between the airport and the port. The first electric buses were delivered in 2016. This bus line is 12.5 kilometers long, and we are operating from about 4 in the morning to 2 hours after midnight, so almost 24/7 at the moment.
Juha, the slides are not changing.
Okay.
So the first slide.
First slide is still there.
Yes.
Okay.
Maybe you should go. Maybe this is too bad to change to the PowerPoint.
So I'll use the PDF.
Yeah, maybe the better, even if it's not presentation mode. Yeah. Sorry about that.
Sorry, it's not your fault. Okay, so we are in this phase. Are you able to see the map?
Yes.
Okay, so one bus is will be driven about 370 kilometers a day. And we have 2 charging stations on the line in both ends of the bus line, and also we have smaller depot chargers for each bus. We are using the bus type we are using is Linker 13 meters long electric bus. It weighs about 10 tons and it's made of aluminium. The motor is electronic motor power is 180 kilowatts, and we are using quite small batteries in the 55 kilowatt hours in power back, and it's a lithium titanate oxide cells used in there, and with that battery we are able to operate about 30 to 50 kilometers. At the moment when it's winter and there's lots of electricity is used to heat up the bus, it's only about 30 kilometers. So like I said, the bus is charged in both ends of the bus line. So one bus is charged about 25 times every day. And we are using inverted roof connected pantograph. And these buses are manufactured in Finland. They were manufactured in Sastamala in Fortaco Group factories. So the quick charging station in the both ends of the line are 350 kilowatts, and they are delivered by Heliox from Netherlands, and the pantograph is manufactured by Schunk. And the charging takes about 5 minutes. So when bus is in the end of line and the passengers are getting in and the driver is selling the tickets, during that time the bus will charge. Depot charges are small ones. They are probably too small in present traffic. The consumption of the buses is quite nice. It's about 1 kilowatt hour per kilometers, and then the heating of the bus is arranged with two parts. There's a heat pump, 15 kilowatts, and an electrical auxiliary heater, 20 kilowatts. And the consumption, you have to remember that it uses electricity also when it's not operating, the bus is not operating. Here's a code of which shows the state of charge in the batteries during the workday. So we will charge the battery up to 85% in the fast charging chargers, and when it gets to the other end of the line, it has dropped to about 30%. Then some observation. We have driven with these buses about over 1.8 million kilometers in Turku. So when the bus line is 12 kilometers, so it means that we have driven about 150 times from 1,000 times from airport to port or vice versa. And at the beginning of this project, there was a lot of questions about will these batteries last and how expensive it will be to change the batteries during these years. But we have now experience for about 4.5 years, and there hasn't been any degradation of the batteries at the moment. The problems with the buses are not with the batteries. Most problems are connected to the unreliability of the buses, and technical problems are not related to the power line of the buses. So the thing that the bus is electric bus, it's not the reason of the problems on this bus line. We have the manufacturer is a small and unexperienced bus manufacturer, so it has been quite a challenge to cooperate with them, and we have found, like in any other this kind of projects, that solving one problem usually causes new problems. There's a curve that shows, this is not the newest one, but it shows the situation that the utilization versus the outdoor temperatures it's quite relevant. So these buses during the winter we have more trouble than in the summertime, and if the summer is hot, it also causes problems. So in optimal situation would be that the temperature, outdoor temperature, would be about 15 degrees, and actually in Turku it's about the average outdoor temperature is about 8 degrees, if I'm remember it right. Everyone is usually asking about the winter effects and how do those buses work during the winter. We have two major problems. One is the charging errors, because every bus charges about 25 times per day, and every charging event is a potential error phase, so it's caused lots of uncertainties. There has been problems with the moisture and isolation problems. The communication between the bus and the charger has also been a problem, and one thing that caused problems is also the positioning of the buses. It's quite you have to be quite and the positioning of the bus is important, and during the winter, when there's ice and snow, it's usually very difficult for the driver. Also, the cabin temperature has been low, and the reason is over there is that the heat pump and the fuel burning heater, which we previously used, it was difficult we were not able to arrange the controlling of that heating system, and last autumn we changed the fuel burning heaters to electric heaters, and which has caused, of course, that the range of the operating range has been more shortened than before. So here's something, some highlights of our experiences in electric buses.
Okay, thank you very much for this presentation. We have questions at the end of the session, so we will move forward to next speaker, who is Mikko Nurmela from Kalmar Cargotec, and he will speak about the work related to electrification of container handling machines. So Mikko, please go ahead. So we have questions at the end of the session. Thank you.
Yes, hello from my side also. Can you hear and see my presentation?
Yes, it's visible. Yes. Go ahead.
Good. So I'm coming from a company called Cargotec, also known as Kalmar, which is actually our brand. But this name Kalmar is much more known by our customers also, so forgive me if I'm using both of these. This presentation gives short glimpse of what are our lessons and learnings from the electrification journey so far. So I'm R&D Manager for Straddle Carriers. Inside Cargotec, we have many different machines, products, and services for container handling or material handling, and also for automation. I'm representing basically these machines, which are designed and developed and designed in Finland, in Tampere. Manufacturing at the moment is in Poland. We used to have also the manufacturing in Tampere, but now it's in Poland. So these machines are called Straddle Carriers or Shuttle Carrier, which is the small machine in the middle. The machine weight is roughly 65 tons. It can lift up weight for 50 ton and machine maximum speed is around 30 kilometers per hour. Depends a little bit on customer specification. Basically, these machines handle the container same way. There are some small differences, like the machine in the middle, it has only 6 wheels, rather than the other bigger machines, they have 8 wheels. Basic machine structure is pretty much the same. We have the same kind of electric drive line in all of these machines. We have three different selections for the powertrain. The traditional conventional one for us is diesel electric, meaning big diesel engine, big generator, which is powering the whole machine, every function in the machine. Then the other one launched in 2013, which is hybrid machine, smaller diesel engine, smaller generator, permanent magnet generator, and relatively small battery pack, also powering the whole machine. And then the last one launched 2016, which is our fast charge machine, where we have removed completely the diesel engine from the machine. And the machine in the middle, the small one, is our fast charge pilot machine in London. It has been there 2.5 years now. Our strategy has been that we are making all the systems by ourselves. We are buying components, but for example, we are making the battery system completely in-house. Same applies to the charging station. When we started the whole development for this fast charge machine, there wasn't this kind of chargers available. So that was quite natural thing to do it ourselves. Also gaining expertise and knowledge, having the complete control of the systems in-house. We started roughly 20 years ago, actually more than 20 years ago. We wanted to do something new which didn't exist on the markets, which is actually the natural thing for R&D to do. The energy saving itself wasn't biggest target. It was more things like less maintenance and energy saving was small target also, but it gained bigger share within next 10 years. Even back then we had a vision that the future for these kind of machines, it will be electric, and that vision was actually 5 years before the markets really accepted this kind of basic electric driveline. It was 10 years before we made the first hybrid machine, and 16 years before the, let's call it full battery driven machine. But even back then, we had quite clear vision that this is the way we go, and we have worked quite hard since then. And the car between on the side of our machine is the Tesla Roadster, and I believe that they had the same kind of vision at the same time. So I've been referring Tesla in other presentations also. They have similar things what we have in the machine: full electric powertrain, traction control, fast charge capability, things like that. Of course, machines like this, they need to be properly designed and simulated and that kind of stuff. At some point, you need to step outside in the real world and start testing the real machine. We have learned many things hard way that what we have not been able to predict in the past, like this traction control for this kind of machine. We had no idea that we would need such a feature in the machine. Machine is 65 ton and it can lift 50 ton, and why would we need traction control? But we were not able to drive the machine in winter conditions, and even if the surface is wet and if there's some oil on the surface, then it is almost the same as winter conditions. we have like Sandvik machines and other machines, we have limited power capabilities in the machine, so we have to develop power control to maintain the control of the diesel engine in the first place, and now for the batteries. And even when we now have better capabilities for simulations, we still need to validate those models in the real world, and that is the thing that where we learn, I would say, the most. So learning hard way. In early stages, we used more industrial components designed for industrial applications, but in most of the cases we have learned hard way that we need some kind of special design for many of these components. So learning by doing what are the real requirements for this kind of machine. Even though we had done these machines from 70s or late 60s, we still had a lot to learn when it came to this electric powertrain. Continuous development and testing. We have had many generations of these machines, and even though we have stopped the older generations of manufacturing those, they had been quite a long list of things to still to develop. New environment or different environmental issues create new issues. Driver is one thing that creates most challenges in our machine. Winter, summer, moisture, vibration, you name it. And automation, we consider automation as one type of driver. We just get the human out of the machine and then let the computer control the machine, and that is one challenging thing to do. In this journey, we have had many unpredictable things, and the latest is actually this global pandemic, and it has opened our eyes even wider than they used to be about this emission reduction. Like Sandvik, in the Sandvik presentation, it was mentioned that it is not the legislation that it is steering the development, but in our case there are customers and their customers, which are in many cases the consumers like us. They are demanding greener production and greener ways to ship the goods from China to Europe and wherever. So this pressure is coming from consumers and our customers, that they have made commitments for certain CO2 targets. During last year, we have not been able to visit our customers as much as we would like to have visited, kind of in R&D purposes and service purposes. So remote services is getting more and more important. Training frontline is absolutely necessary in this kind of new technologies. We are not able to go everywhere in the world, so we need trained people in the frontline, and that is one thing that we should have done much more than we have done. Like I said, yeah, customers are making their own targets for this emission CO2 emissions, which is creating growing interest on these eco-efficient, eco-friendly products. Yeah, that was actually briefly what we had. Couple of points to highlight is the training of the service personnel. If we are talking about this kind of global operation, global machines, we need to have this expertise in close to the customer.
Okay, thank you, Mikko. There's a few questions, but we take them after the last presentation, which is by Harry Lilja from Micropower Group Finland. And he will remind us that every battery needs a charger. Go ahead, Harry. So we have questions after this.
Okay, hopefully you can see this now. Can you see the presentation?
Yes.
Okay, so thank you for having me also, and best regards from Salo. I'm Harry Lilja, Managing Director for Micropower. Not so well-known company, so I will tell a short story about our company development. We've been here for a long time, but as I said, we're not so well known, and I think the charger definitely is the best friend of the battery, and every battery needs a charger or even several chargers. So let's have a look at our story. This story begins actually simultaneously in Sweden and Finland. So in 1984, three partners founded a small company called Micropower in a garage in Växjö, Småland, and they wanted to develop and sell high-quality transformer-based battery chargers. And they were quite successful, and without any external funding, they slowly grew the company. And in 2003, they had reached about 9 million euro in revenues. So at the same time, there was similar kind of development in Salo, Finland. Three guys here also founded a company called PowerFin, also in a small garage. And also here the target was to develop and sell high-quality battery chargers. Here in Finland, they were based on modern switching mode technologies, so really state-of-the-art at the time. And also here, the business was growing nicely, slowly but steadily, and totally organically. And in the late 90s, actually, Micropower in Sweden quickly became the largest customer for PowerFin. And in 2003, we had reached about 2 million euro, so combined 11 million euro business. So not that much, but this is 20 years ago. Then in 2003, Micropower decided to acquire PowerFin. So basically, the largest customer bought its key supplier. And this was a nice match because the chargers that were developed and manufactured in Salo versus those in Växjö, they really complemented each other. So there was no let's say, overlaps. And the customers already at that time were found in electrical trucks mainly, some kind of utility vehicles and different moving machines. So basically all other electric vehicles, but not the mainstream automotive market. And let's say divisional work here in Salo, we have all the time focused on chargers which are working from one phase, 230 volt AC input, sorry, and the power levels are from about 600 watt to 3.2 kilowatt for a module. And Växjö again, they have larger chargers, so they work on three phase, 400 volt AC input, and module size starts with 5 kilowatt that go up to systems to close to 100 kilowatt actually. This way, this combined Nordic group was growing through the years, not anything spectacular, but this is kind of a traditional industrial market really, or has been. And in 2017, we reached a combined 45 million euro business. Then we actually stepped on the acceleration pedal and started with lithium ion. And in Sweden, things advanced very rapidly. So a small startup company was acquired to Micropower Group with some experts in lithium-ion business and really pioneers in battery development in that area. And they had this concept called Lion Bricks, which the idea was that we actually offer a total complete concept to our customers. Meaning we had a battery module, which is like a Lego piece you can assemble in different combinations and different form factors. Then, of course, we need the electrical steering system, the battery management system. And to have a complete system, the customer also needs a charger that is integrated into this complete system. And because being a privately owned small company, we could do this development and launching to the market in really fast time. The first production cell actually opened in Växjö in early 2018 already for the battery modules. And at the same time, here in Salo, we moved into the old Nokia premises factory, Nakola factory here at Salo IoT campus. So we tripled our area here in Salo, and in Växjö, about 10 million euro investment in a battery factory, which is actually up and running in Växjö. Total output will be around 1 gigawatt hours when this is fully populated. But we are shipping tens of thousands of modules every month as we speak from the Swedish factory. So what does it mean for Finland and Salo and the whole ecosystem here? Of course, we are the charger experts here, and if I just have some, let's say, overview of how the charger products have really developed during the last 20-25 years. So it has been a quite big change and evolution. If you think about chargers in general, they must be really reliable. They cannot be down. They have to have high efficiency. This is good for you need less cooling and then of course also less energy consumption. Ideally, they are very compact and of course they are commercially competitive. That's clear. Then there are some general requirements for chargers, of course. Easy to use, easy to install, kind of user-friendly. Good to handle over voltage, short-circuit situation. They can come to life again after that kind of situations. Maybe there's an external fuse that can be serviced out in the field, which it's a good feature. There might be some relays for alarms or remote connections, LEDs for stating status and analog control and other functions for steering the unit. So and CAN bus or other communication also, of course, used to be optional. Now it's almost mandatory. So Sharp 20 has been our traditional series of products, and this is really something that is more like a black box, even if the color here is red. So we have different voltage versions. Yes, it's an IP20 enclosure, so basically it's for indoor use, office type of conditions. There's a LED indicator saying if it's okay or not okay, or charging or charging has been interrupted. There's an internal fuse, so if something goes wrong, it has to be shipped to factory for maintenance. Usually there are preloaded charging curves, and a customer can, with some switch, select which one he wants to use. Outside control is usually limited to some kind of analog control with small voltage. You can steer in the charger on those voltage and current levels you want. And efficiency is not mind-boggling, about something around 86. So this is the traditional charger we have seen for last 20 years, let's say. And how is the future and what are we working on now? So with the lithium-ion, things have really changed and we're going more into system level. Lion 30 is our latest line of chargers, and as you can see from the picture, this is already starting to look like a system. Still, there are different voltage versions. Definitely, the voltages are going up higher all the time. IP classes for chargers are definitely going to be higher as well. These are good to be in outdoor conditions and on board moving vehicles, so they have to tolerate vibrations and water and so on. Nowadays, users want to have user interfaces. There are displays, there are buttons that they can directly operate on the unit. There's an external fuse. If something goes wrong, it can be key exchanged in the field. Also here we have still preloaded charging curves from factory, but to more and more extent, the BMS will control what the unit does in the system. And of course, CAN bus connection is basically a must when you work with lithium-ion. This is the normal way of communication with the BMS and the total system. Also, the new generation of chargers are cloud connected. We have a system called GET, which is kind of a either it's a fleet control system, basically, either working with a radio connector or on an NFC connection. So you can load data out of the charger, parameters, history of charging, and then you can also load in new parameters or charging curves into the charger if you want to. So basically going from black box to this kind of system level has happened in chargers, and a lot of things are happening right now. There are so many different electrification projects going on in let's say utility vehicles and moving machines and off-road vehicles in general. So we have a really active phase now in Salo here with chargers, and also in our group as a whole. We are in Salo manufacturing about 40,000 chargers a year. So we are a small niche supplier, but we are in very many interesting applications with batteries, of course, always part of the palette. So this was on fast tempo what I wanted to share about our company. Maybe this was more a PR session for that we are existing and we are not so well known. So I think we can then continue and hopefully have a good cooperation in the Finnish and Nordic ecosystem. Thank you.
Thank you, Harry. Now we'll slightly late behind the schedule, but I will take one question per each speaker. First goes to the Juha Parkkonen about can these buses be charged by CCS connector?
Yeah, in buses there's two ways to charge them. One is the pantograph over which connects the charging connectors in the roof of the bus. That is 350 volts kilowatts charger. But then there's also a plug. You can connect the bus with the cable which we are using in the depots.
Okay, I guess that's a good enough answer. If more answers needed, please send emails or contact more. So next question goes to the Kalmar side. What is the battery chemistry used in Kalmar products?
We are not disclosing this or discussing this kind of specifics in
Okay.
public. We try to maintain our competitive advantage on the markets.
Okay, then I guess we don't have questions for Harry. So then I guess we move forward for a break. We have a 5-minute break now. And if you have more questions to the speakers, please send emails, or you can still send the questions to this chat group. So now we have a break until 11:45, so 5 minutes. So then Johanna will take over the session. Thank you.